Hello, welcome to our Semiconductor education program. I'm Vincent Chang. In this lecture video, I'm going to explain and go deeper to explain how to calculate the output resistance of the active low differential amplifiers. Here's the BJT active low differential amplifier. If you can remember, the first 5 steps to analyze this, to do the small signal analysis, is this: purple, green, and 2 blue. And number 5 is the sum of the number 2 current alpha IE from the bottom, and number 4 current alpha IE from the top is the double of the alpha IE. The first 5 steps. And then we use the Norton equivalent to consolidate the whole circuit into the 2 very simple components. Number 1 is the voltage control current source, GMVD. And number 2 is the output resistance. But what is the output resistance? We've shown before in the previous video, part 1. It's this. It's a parallel combination between R2 and R4. Let me ask you this. Are you really convinced this is the right output resistance? This is the right answer for the output resistance? Are you really convinced? Do you believe that? Do you have any doubt? Now, I want you to stop and think. How to calculate the output resistance? Or if I don't give you this answer, what will be your answer for the output resistance? Let me repeat that. So I'm challenging you to stop and think. What would be your answer for the output resistance? So let's pause for 5 minutes for you to think about my question. What will be your answer for the output resistance of the active low differential amplifier? So what's the issue? What is the issue? I think one of the doubts that you might have during the break, during the 5 minutes, is if you pay attention, the common emitter terminal is not grounded. If the common emitter terminal is not grounded, that means what? Means the emitter base junction AC, okay? The AC voltage of the emitter base junction Q2 is not 0. Voltage control current source, if VBE is not 0, AC, okay? Not DC, we are doing the AC analysis. Don't get confused between DC and AC. We are not doing the AC analysis. So the VBE2 is not 0. Then you have to consider the voltage control current source inside the transistor. So there are 2 components working. GM VB2 in parallel with R2. So how can you say when you're looking down it's the R2? Important concept. Always remember, when someone asks you to calculate the output resistance, what is the first step? Set Vi equals 0. So the 2 input terminal should be pulled down to AC ground. Look at the left-hand side. Now VD is 0. The brown grounded. Brown or yeah, it's brown, okay? So the VD is 0, then see the right-hand side. 1, VD is 0. When VD is 0, then voltage control current source, GMVD becomes what? Open. Open. So 1, VI 0, 2, open. Then what? Then the output terminal to ground, only 1 resistance is left. The only one left resistance is called the output resistance. In other words, if you look at the left-hand side, now you see 4 transistors and ground, Q1, Q2, Q3, Q4, right? So we consolidate these 4 transistors into one single resistance. We're going to find out one single resistance. That's the output resistance. All right? You got it? But how? It's a little bit complicated. Now the common emitter terminal is not grounded. VB is not 0. Voltage control current source has to be considered. I'm talking about the Q2. But how? It's a little bit complicated on the left-hand side. So we test it. We try to test. We try to measure. So we put on a testing voltage, a voltage generator, the AC generator from the outside. Just imagine there is a test voltage generator from the external output terminal, and then there's a current flowing from the generator. Testing voltage and testing current. Try to find out the relationship between these two. Relationship between IT and VT will give you the answer. Why? Because VT equals IT times R out. So the ratio VT divided by IT tells us the answer. Let's put on the R4. Also the R2. Then what do you see? Do you still believe the answer is the parallel combination of R2 and R4? How about this? Capital, the blue one, the capital R2. So the capital R2 is the orange block. The orange block, the equivalent resistance of the orange block between the dashed line and the ground. So what is the good answer for the capital R2? It's this. The R2 on the left-hand side is a little bit complicated, challenging this lecture video compared to the previous part 1. So you need to pay attention. Capital R2 and on the left and the capital R2 on the right. Q2, right? So what's the emitter resistance of Q2? The external one. It's actually the resistance between emitter of Q1 and grounded looking into emitter. So what is that? RE. The yellow resistance looking into emitter. Again, it's the emitter resistance between emitter and the base, the resistance between emitter and base, and looking into emitter. So it's the RE of Q1, right? Red corresponding to red is the RE1. Now, to take the weapon, okay, the skill, you should have this skill very familiar. You should be just write down this within 10 seconds. RO plus what? 1 plus mu external RE in parallel with R pi. R pi 2 in parallel with RE1. And then, because the RE is much smaller than R pi 2, so R pi 2 is negligible. So 1 plus GM2R2, which is mu times RE1. And then GMRO is much larger than 1. 1 is negligible. GM times RE equals, are you with me? GM times RE equals alpha, right? So alpha is approximately equal to 1, 2, double. Have you ever thought about the double? So the capital R2 is the green R2, the double of the individual R2. So it's not multiplied, R2 is not multiplied by 50 or 100. It's multiplied by 2. It's double. Therefore, if the equivalent resistance of the orange block is capital R2. So now the current going down, the red current is the VT divided by R2. So there's a current. And then this red current will go this way, right? In equals out, KCL. And then the current will keep flowing up here. Mirror, current mirror. IE1 touches, once the IE1 touches the current mirror, on the first order level, ideally, you would reproduce another current on the right hand side, IE1. But this is the ideal, the first order. I said my word very carefully. First order, but you need to consider second order, channel length modulation effect, the output resistance, channel length modulation effect. So there's more current flowing through R4, this current. The sum of these two current is the IT2. So the total test current is the sum of these two currents. IE1 going down, IE2 going up. So now we are closing, we are almost done with this. So you can put on, replace IE1 with VT divided by capital R2. And then IE1 and green current. Then when you what do you see? You see this. So what's this? Bingo! The parallel combination between R2 and R4 is the answer indeed. So I'm not kidding. So it seems a little bit magic, right? So this reminds me of a quote. Everything should be made as simple as possible, but not simpler. Not simpler. Who said this? Albert Einstein. Albert Einstein said this. Interesting, huh? Takeaway. Concept. Always remember, the first step to calculate the output resistance is to set the external signal source grounded. Number one, very simple. Number two, the result is also simple. The final result is also simple. The parallel combination between R2 and R4 is the output resistance of the whole active low differential amplifier. But the insight is deep. But the insight is tough. So result simple, insight tough. What insight? What kind of insight do you get? Number one, the common emitter terminal is not grounded. So therefore the R2 will be multiplied, but not that much, not 50, 100 times, but double. Why double? It's this. Go back and review this. Double. 2 R2. This is the first insight. And the second insight is the mirror has the effect. Once the IE1 touches the mirror, there's the first order copy, the first order duplication. So the current mirror also has an impact upon the output resistance. Very interesting lecture, but kind of deep and challenging. So I really hope that you can learn something, especially the third takeaway, the insight from this lecture, and you'll feel rewarded. So your skill, your learning, your understanding now is deeper. All right, I hope you enjoyed today's lecture, learn something. Thanks for watching.